All right, let's get back to this and finish this series. Sorry for the delay for those of you guys that watch as soon as I make releases, but I've got a major project at my real job that I've been doing, so it's taken up a lot of my time, but we'll try to squeeze this series conclusion out for this weekend. And what we're going to do is, of course, I think we're on the second part of the series now. We've just completed the understanding of the MAF and how to do some basic measurements and things like that. So now we're going to get into the diagnosis of problems you might have with the MAF. And then there was going to be a third part on tying everything together and the map versus the map. I think I may do that on a whole separate video. So we'll conclude this out with the actual diagnostic part. So as mentioned when we left off, there are 4 possibilities that you would have that you'd want to narrow down in a diagnosis, and we will run through all of these, but actually not in this order. So one thing I think we'll do is, especially since I always try to make my videos for the hardcore viewers, let's do a quick review because it's been a while, and we'll do that with an actual kind of case study here, sort of a simple one. An actual email that I got from a viewer, and he was chasing down a lean condition, so he was watching several videos. This was before the MAF video was even released, and he decided to suspect his MAF sensor, so he uses a DVOM on the MAF sensor. He has 3-wire MAF. He gets approximately a 7-volt reading with no change no matter what RPM he's at. Anything he does, the voltage never changes. And he's thinking, well, this must be indication of a bad mass airflow sensor. So based on what we remember and our understanding of the operation of the mass airflow sensor, what would you tell this guy in this case with this data? And we'll make a multiple choice out of this. So would you say that the problem is he has a digital MAF and therefore cannot measure using a DVOM? His MAF sensor is indeed actually bad. He has a grounded signal wire to the MAF, or he is measuring it wrong. So what would your answer be? Without question, this guy is measuring his MAF wrong. So if we remember, on the MAF sensor, you're going to have either 3 or 4 wires. He's got a 3-wire, and those 3 wires are going to be the 12-volt power for the actual wire itself, of course. You're going to have the ground for the wire, and the ground also serves for the 5-volt reference. What he was obviously doing was measuring here and here with his DVOM, which of course is going to give you the difference in voltage, 7 volts. That is not going to change regardless of his RPMs. So that's obviously what his problem was there, is he didn't measure correctly. So just another example of how understanding the components you're working with will help you to take the right measurements in the first place. So for the other answers, I kind of forgot what they were. The first one was, that it was a digital MAF. Obviously, we don't have enough information if it was a digital MAF. Had he measured between that signal wire and the ground, if he had read 5 volts with the key on, then almost certainly, of course, it's going to be a digital MAF. And if he had read closer to 0 volts, then almost certainly it would have been an analog MAF. But because it's pretty clear he didn't measure the ground, we don't know that. As a matter of fact, we don't even know that the ground is good, except that a bad ground would have certainly caused a mass airflow error code as opposed to just a lean code. And another choice was that the signal wire was grounding out. That makes no sense whatsoever. Hopefully you didn't choose that. If you did, you'll want to look back at some other videos with some more basic electrical foundation. And of course, the third possibility was a bad MAF sensor. No conclusion could be drawn on that in any way whatsoever. As a matter of fact, no testing on the MAF sensor itself was even done through that. Only testing for the feed to the MAF technically was done. So hopefully that makes it clear to you. Okay, so let's run through our 4 diagnostic possibilities that we would want to narrow down. And the first one we're going to do is a wiring problem, because I think that's the easiest, especially given what we did in the previous video. So let's run through how we would do the wiring integrity. Basically, we kind of already did this before. So obviously, understanding our MAF application here, We've got a 3-wire sensor. We, of course, may not even know which wire is which, but we're going to look and verify that we've got a power, a ground, and a signal. Okay, so if I just go ahead and probe these two here, we see that I get almost 7 volts, so obviously that's what that other guy did. That's clearly my power and my signal. That alone, even though it's kind of not an intended thing there, does tell us that we clearly have power and signal. So then if we go over here, we should measure the ground. And of course, we can see we've got 12 volts for ground there. So that right there, just that simple test tells me that my wiring integrity to the MAF sensor is good. And just for the purist to show that we do have correct 5-volt signal, if I go ahead and probe the signal on the ground, there's our 5-volt signal showing right there. So again, if we found that that was not the case, we would not condemn the MAF sensor. Actually, almost certainly in that case, your MAF sensor is probably good, and you've got some type of wiring integrity problem for whatever you're missing, whether it's a ground, whether it's power, whatever. So another way you can do that would be with a test light, and a lot of people pointing out that I never use a test light in my videos, and can I start using a test light? I mean, there's really no difference here. I just like the voltmeter because I've got a lot more flexibility with just changing the dial to the various settings. But you can do a test light if you want. So I'll have my test light connected to the battery ground, and then I can just poke around until I find it light up. You can see hopefully right there in the camera that it does light up there. So that's indication that I've obviously got my 12-volt power. It does light up a little bit with the 5-volt reference, but it doesn't indicate the amount of voltage you get. I could, of course, also switch my test light over to battery positive and test a ground that way. Not one of my favorite things to do with this test light. I'm safe doing that. This is a computer safe test light, but you got to remember again, if I'm doing that and you're not aware what you're doing, or you're using the wrong equipment and you're actually jumping that 12 volt through the ground, that's going to be a bad idea. But with this test light, that wouldn't be a concern. We certainly could do that. But obviously the point is, whatever method you do, I think one of the easiest things to do for the MAF sensor is rule out your wiring. Obviously this one being only a 3-wire is easy. On the multiple wire sensors where you've got that IAT integrated, you will have to discern which wiring is for the IAT and which is for the MAF, and we did that in the previous video. And if you do find that you have a wiring feed issue, I do have several other videos that show you how you would trace those from the sensor on back, even all the way up to the PCM in one video, so maybe I'll put links to those. But once you confirm that your wiring integrity is good, your next thing, you of course want to test the sensor itself. This is a GM 3-wire MAF sensor. This I actually think, if I remember, this I think is one I've got from my Trans Am before I put the aftermarket one in. So obviously we haven't taken a look at one of these up close before, but you can see these little filaments in there with the little resistors. Those are your MAF hot wires, and a very common problem is these getting dirty. We will cover that, of course, with the inaccurate MAF reading, a very, very, very common problem. And obviously we can see these kind of remind me a little bit of the filaments in a light bulb, and they're very thin and delicate like that, and they can break. So that's one of the first tests we're going to do, especially if we had a MAF error code, is do we have a lack of continuity from the power feed through the ground, something similar to like a broken light bulb filament where we cannot power that hot wire. So let me check real quick, because I think the wiring pattern is different on this one than the aftermarket. And indeed it is. It goes power, ground, signal on this one. So the first thing we're going to want to do is, of course, make sure that we have continuity between the power and the ground. If we did not, then that would be 100% indication we've got us a bad MAF sensor. So let's go ahead and put that on there, and we can see that we do have continuity. Now, there often will be an actual resistance specification as well here. And as a matter of fact, let me go ahead and look up if there is one. And in my service manual, there is actually no indication for a resistance in here whatsoever, but there actually are a couple for frequency readings that the PCM would look for instead of DTC. So of course we would have to know those, and then when we do frequency testing on the sensor, that would be a good diagnostic test. But for our continuity test, this would suffice that we clearly have continuity between the power and the ground. Now another thing that you'll want to do here, and you can also do this of course on the car as well if you wish, you don't have to remove the sensor, but you want to be very gentle with this, but tapping that MAF sensor just in case the wire is broken but it's making intermittent contact, and you would see a dropout here. We can see that we don't have any dropout, and of course this is probably better done of course with a scope because of the speed, as well as doing this on the car, maybe with the car running and using a scan tool or something to look for dropouts. But that's something you want to consider with those MAF wires, and we don't have any indication of problems there. Now the other thing we want to do, intuitively you would think we want continuity of course between the 5-volt reference and the ground, and we do not actually want that if we think about it, because that would be variable. So let's just test that, and we can see we do not have that. We would need power to this sensor, and of course it would vary based on the amount of flow. If we had continuity here, that would be indication of a bad MAF sensor. We would have some kind of short with the signal and the ground internal in the MAF circuitry, and that would be without question an indication of a bad MAF sensor problem. And while we've got this out here, one other thing to point out is this MAF sensor screen. Back in the day when I used to hang on the forums and everything, and one day, you know, especially now with racing season starting up, I will have to do some performance related videos. One of the things that everybody and their grandma on all of the wannabe performance forums talked about is removing this MAF sensor screen. It's that extremely narrow-minded ignorance of anything that is a restriction to airflow is inhibiting performance with your vehicle. And while there's certainly no argument that more airflow is better for performance, there's no, it's a basic foundation. The problem is that also accurate measurement of that airflow is necessary, and that is actually the purpose of this screen. And what I'm getting at is the modification that a lot of boneheads would do, and I'm talking thousands of people, where the idea to remove this mass airflow screen, thinking that the screen is to protect the delicate wires. That is not the purpose of it. If you think about it just for a second, the air filter would do a million times better job than this screen would of that particular application. So the purpose of the screen is actually to even out the airflow so that there is an even sampling from the mass airflow sensors for the airflow coming in. Without the screen, you would have a huge turbulence coming in there, and what would happen is more air would come into the engine than what is measured by the mass airflow sensors. Because of the variability of the turbulence in the airflow, you would lean out your car. Rule number one, if you are into performance, do not lean your car out. If anything, you want to side rich, if anything. So the interesting thing about this is a mass airflow sensor is very expensive, maybe $300, $400 and up. So destroying a $400 part to make your car slower, not what I would consider a really effective performance mod, but I just wanted to throw that in there. And we actually jumped ahead to the bad MAF sensor inadvertently, but we'll go ahead with that and do some frequency measurements now. But if you also wanted some data and stuff on what I mentioned about that MAF screen, that'll be coming up in a future video where I actually show that and some other bonehead mods. People who want to do performance, good God, they get such narrow-minded, and you know where it all stems from, by the way? Those frickin' chat rooms and forums, I swear to God. But let's stay on track here and look at some other indications with the bad MAF sensor, and that would be a failure to get any kind of signal change indicating a problem with the MAF circuitry. So let's go ahead and look at how we would diagnose that. Okay, let me go ahead and set up our scan tool, because we're going to measure the digital MAF first, which will be different than the measurements for the analog, of course. And as I mentioned at the beginning of this series, you are not going to be able to do a comprehensive MAF sensor diagnosis on a digital sensor unless you have either a scan tool, a oscilloscope, or a rather advanced DVOM, not like the one that I own, where there is actually a frequency measurement capability. And even then, the frequency specifications for some MAF sensors may far outrange those on your DVOM. So you've got to make sure that you've got it well within range. It would be a fairly pricey DVOM that would be able to do that type of feature. If you do not have one of those three things, you are not going to be able to do these more advanced diagnostic tests. You will not be able to conclusively condemn a MAF sensor. So that's just the reality of it. You know, you have to have the right tools for the job. So let me go ahead and set this up and I'll show you what we're looking for. Okay, and while this sets up, I already looked up my specifications in a service manual. It states that at idle, we're going to look for somewhere around 2,000 hertz, and at full throttle, as many as 10,000 hertz. And of course, that would be different with the car at park, sitting here versus actually driving and having more air traveling through because of the speed of the car. But let's go ahead and see if we can find our PIDs. All right, so if we look at here, we've got a indication of the pounds per minute. There may also be a specification there, but we're looking for frequency. And we can see our mass airflow frequency is a little bit high, but again, this is normal for my car because of some modifications I've done. But this is what we would expect. We should see a dramatic increase. It went up to about 6,000 there. If, on the other hand, you don't have a scan tool, but you do have a frequency meter, which likely you may have never used until this video before, well, now you can put it to use. Obviously, we'll want to probe between our signal wire and our ground. And then you'll want to set your meter to probably a 10 kilohertz should be just fine for most measurements. A 20 would certainly cover the range a little better on this model, but we'll go ahead and set it there and start the car. And we can see we're reading about the same as we did before. Got up to 6 as our highest reading again. All right, so obviously, you know, kind of repetitive what we did before, so I won't really show that on the analog. Same thing with the analog, you would go between your signal wire and your ground, and similar to testing a TPS sensor, the more you increase the throttle, there should be proportionate change that you would measure. So the point of it is what if you are out of spec with those readings in either case? And in either case, being out of spec is going to fall under the category of an inaccurate MAF sensor. Where almost certainly the MAF sensor itself is not the problem, possibly in the case if you've got too high of frequencies or too high of voltages, we'll talk about that. But obviously your possibilities are, with the case of your frequency or voltage, it would either be below specification or it would be well above specification. Below specification, far more common, so we'll cover that second. If you find that you are at very high frequencies, most likely these are not PCM problems, but a thing to look for with high voltage or high frequency would be the routing of your MAF wiring. If it's going through ignition coil wiring or something like that, some type of high voltage source, that can sometimes cause an inaccurate high MAF voltage or especially a frequency reading. So that's something to keep in mind. Not quite so common. Your much more common reading is the low frequency or low voltage. And very, very often that's going to be caused by one of the most common MAF problems, and that is a dirty mass airflow sensor. And that is particularly the case with the hot wire MAF because the heat will cause foreign particles to kind of stick onto the wire and accumulate over time. So in your dirty mass airflow sensor, you've got your MAF wire there, and of course, as you've seen, maybe a couple resistors or whatever. And what will happen is you will get the wire covered in some particulate matter. Very often it looks kind of like ash. I wish I had an actual example of it. I've certainly seen many of them. Some of them so dirty that it almost looks like it's caked in this sort of fibrous, ashy substance. And basically what happens is if your airflow is coming through here, remember from the very beginning how this hot wire works is you've got your 12-volt source going through there, and of course the idea is that you're maintaining a temperature of that wire. Well, now you've got a problem because that wire is insulated. If the wire is insulated, then less current will be necessary to maintain the wire temperature, and it's actually amplified with as more and more air comes in. That delta of what you normally would need to heat the wire up to prevent it from cooling down here, well, that's nullified by this insulating effect. So basically what's going to happen is you're going to see lower voltage readings. You're going to definitely see much lower frequency readings because you need less on time for that duty cycle. So what's going to happen here is you're actually going to run a very lean condition, because what's going to happen is much more air is going to pass over the MAF sensor than what is measured by the wire. And if more air comes in, basically for all practical purposes, it's like a vacuum leak, except it's a vacuum leak that happens the more that you're on the throttle. So in a way, it's the opposite of a typical actual literal vacuum leak. So let's look at how this would affect your system. So tying this in with everything else we know, including fuel trim, this can be a situation which can, depending on your system, wreak various forms of havoc, everything from just a simple lean condition to the referenced codes, which I've mentioned earlier. But of course, you're going to have your air coming in there, but because the MAF wire, the blue wire here, is covered in these red contaminants, that wire is insulated. So that means more air is coming in than what the MAF is measuring. In other words, obviously a lean condition, because of course we've got fuel that is added based on the measurement initially from that mass airflow sensor. It's a very accurate system that is going to be your initial indicator for how much fuel is needed. But of course, we are not going to be at that 14.7 to 1 ratio because there is going to be much higher air. So we may be at a higher ratio here. But of course, the PCM doesn't really know why, because it thinks that there is definitely response from the MAF sensor. And there is, it's just a little bit lower. So obviously what's going to happen here, we've got our combustion. Then when we get to the O2 sensor, the O2 sensor starts reading lean. That of course is going to cause the fuel trim to add for the addition of fuel, so that we can bring this ratio back to 14.71 typical lean condition response. Now the problem is that your MAP sensor and your throttle position sensor are going to be in agreement with each other pretty much, because the amount of throttle position opening is going to of course affect your MAP reading, and we've already seen videos where those talk to each other. So in one way or another, most likely this is going to point to a MAF code. I've never actually seen that happen. Usually you get the lean condition code first before you get that MAF so dirty that it actually has too low of a voltage or too low of a frequency to reach that threshold. Your threshold for the fuel trim is going to be much more sensitive than that for the frequency or the voltage on the MAF. So I hope that makes sense. So on a lean condition, one of the things that I'll look for on, if I'm suspecting a dirty MAF sensor, is a particular pattern on my scan tool that would indicate the MAF sensor is to be suspected. So barring an actual MAF error code, but a lean code where I'm suspecting an air induction problem, what I'll do is I'll, on my scan tool, graph my long-term fuel trim against RPM. And typically what I'll find is if we look at our scales, with blue being a long-term fuel trim scale and red being an RPM scale, at idle, typically what I'll see is a fairly high fuel trim, maybe usually around, I don't know, maybe 8 to 10 or so, a fairly high fuel trim. And I know that other videos, I know my very good friend Paul Danner has indicated that sometimes you'll see a rich condition actually with your fuel trim on a dirty MAF at idle. I personally have never seen that. I've only ever seen a consistent high fuel trim, but I'm definitely not going to say don't take his word for it. Most definitely, I would agree. If Paul Danner is telling you that you can get a rich condition with a dirty mass airflow at idle, definitely go ahead with that. I've just never personally see it. But what I see is as you increase your RPM, you are going to get an increase proportionately almost with the fuel trim, and at approximately 2,500 to 3,000 RPM, if the MAF sensor is dirty enough, you will just simply max out that fuel trim. And of course, both of them will come back down again as you let off the pedal. But basically this fuel trim with the additional call for fuel as you increase your RPM indicates to me one of two things. That's going to indicate either we have a fuel deficit problem, so that is the amount of air coming in is accurately measured, but the fuel pump cannot deliver enough fuel. So some type of fuel pump problem, line restriction, filter restriction, injector problem, whatever. Or we are underestimating the amount of air coming in, so that is the indication, of course, of a dirty mass airflow sensor or some other air restriction problem, but most likely the mass airflow sensor. In this case, what I'll do to narrow down, typically you can just measure fuel pressure and rule out the fuel pressure. That's not always easy to do, as we've seen on most cars, especially if they don't have a Schrader valve. But what I'll do is I'll start actually looking at my MAP and MAF data. We already did a video on MAP data, and if the MAP data looks good, and especially remembering that MAP data is going to have a minimal effect on your fuel trim over the MAP really doing other things in a MAF engine, and we'll talk in another video about engines that do not use the MAF sensor. But if this checks out okay, then what I'll start looking for is my frequency or voltage using the scan tool on the MAF sensor and seeing if those look a little bit low or out of spec. Now, of course, this requires you to have some baseline information, but on most GM models, if I see anything under 1800 hertz on my scan tool, I'm very, very, very strongly going to suspect that this is caused by a dirty mass airflow sensor, and I'll go and I'll clean the MAF sensor, recheck my data after that, and verify that my short-term fuel trims then start negating my long-terms. But I'll actually go ahead and show you some actual data from a dirty mass airflow sensor on a previous vehicle I did. Okay, so here we have the data from a vehicle that actually I got burned on, a Toyota actually, and I'll tell that story after this. But what we've got is the data, and these top two graphs are the one of interest. This is short-term fuel trim down here. This is the bank 1, bank 2 long-term fuel trim. And up here we've got in red the mass airflow pounds per minute and throttle position. I did not have RPM on this one, would have been nice, I guess. But what we can see here with the dirty mass airflow is exactly what I had described. As we increase even just very slightly in throttle position, look at the very high responses that we're getting from the long-term fuel trim on both banks. And then we can see that when we're at idle, the fuel trim is actually perfectly normal. And then a real telling factor that indicates the MAF sensor with this particular problem is looking up here. We again, with more aggressive throttle position angles, higher RPM, notice how the MAF sensor does not even remotely proportionately increase over what it did with the lower throttle responses, and yet we still get these very high fuel trims. So again, indicating that the MAF sensor is not doing a very good job of accurately measure what's coming in. Okay, and with that, I will actually tell you that on that same car was actually one of my very few diagnostic failures. But what actually happened on that car, everybody loves to hear about other people's failures. A lot of people, I'm sure, especially mine. It was very obvious to me that that was a mass airflow sensor problem on that car. So I diagnosed dirty mass airflow sensor as being the likely issue. And I went ahead and I cleaned the mass airflow sensor. Now, when I did that, I did not pay attention that this vehicle actually had a, I believe it was a 6, it was either a 5 or a 6 wire mass airflow sensor. So as stated at the beginning of the video, this means that there were actually 2 components here. One of them was, of course, going to be the IAT. Which actually had a little kind of resistor looking thing on it. And then of course, the other components here would have been, I believe it had 2 grounds, one for the power wire, one for the 5-volt reference. It had a hot wire MAF here. And the mistake that I made when I removed the mass airflow sensor from this vehicle and took a look inside, I saw that there was indeed some dirt on this wire here, but I did not realize that it was actually the intake air temperature sensor that was built in to this unit. And I went ahead, cleaned it off with my mass airflow sensor cleaner. It was nice and bright and shiny. And I went ahead and I put it back into the vehicle. And of course, the vehicle still had the stumbling problems and the extremely high fuel trim with even just a minor amount of throttle. Well, then the problem was, at the time, I did not have the fuel gauge set up to do a fuel pressure test on the vehicle, but I started to look at it and think, well, the only possibility left has to be that there's some type of fuel pressure problem. And because I could not measure the fuel pressure, and because I eliminated the MAF sensor as being a possibility because I cleaned it and I was sure it was clean, it has to be a fuel pressure thing. And so inevitably it led to me replacing the fuel pump. After replacing the fuel pump and it did not fix the car, I obviously had to swallow the price of the fuel pump because I was wrong. And I could not for the life of me figure out what was wrong, did a little more research, come to find out that the mass airflow sensor wire on this model is kind of hidden in this composite unit. And of course, when I looked at it, it was absolutely, completely covered with dirt. When I went ahead, used my throttle cleaner or my mass airflow sensor cleaner to clean off all that dirt from the correct component, the car just absolutely ran beautifully. So again, knowing your components, I would have paid much more special attention and asked myself, am I really cleaning the mass airflow sensor? How do I know that I'm not just cleaning the IAT? And this brings us to our final thing, and looks like my marker's about to die here, but that would be the referenced MAF code. So one of the things is that other than a dirty mass airflow sensor, I will tell you that with a mass airflow code, which I've only seen a couple of before, and it was indeed like a broken MAF wire or something like that. As far as for the majority of people, when they come to suspect a MAF sensor, it's usually because they have a lean condition and they've done their usual plugs, wires, O2 sensors, everything like that. They've generally avoided doing the mass airflow sensor as one of their parts changing experiments because the MAF sensor tends to be very expensive on a lot of models. I know on my Trans Am here, I think it's like $400 or something. So the problem is they don't want to replace the MAF sensor because they want to replace all the cheaper parts first. Then eventually they get around to the idea, usually from the chat rooms and forums, that their lean condition, which would be an 0171 or 4, or maybe even a rich condition, must be because of inaccurate induction measurement with the incoming air. They're going to start pointing to the MAF sensor. Now, don't forget, replacing the MAF sensor erroneously is not a $400 mistake. It's more like kind of a $700 mistake because you've replaced the plugs, wires, O2 sensors, everything else before. So by the time you got to the MAF sensor, most people have already dumped $300 into trying to solve their problem. In my experience, and granted it's fairly limited, I have yet to see a faulty MAF sensor, other than it being dirty, a faulty MAF sensor causing a lean condition code. So right off the bat, if you have a lean condition code and you are in the direction one way or another that you believe you have to replace your MAF sensor, my advice is to recheck your work and make sure that you are at a definitive, conclusive endpoint there with your data. Now, technically, that's not a referenced MAF code. What a referenced MAF code is when the computer is showing you that you have a mass airflow code, and it's not the mass airflow sensor that's the problem. A great example of this, the previous video on the Volkswagen. You have to keep in mind, we have many different things that are involved in measuring air induction on the car, and that an inaccuracy with any of these components can cause a referenced code or an erroneous code to be thrown on any of the other components. In the Volkswagen, it was a timing problem because the amount of air coming in was not matching, obviously, the amount of oxygen measured at the exhaust, and it was because of a cam crank timing problem. One of the things we saw was a MAF specific error code, even though the mass airflow sensor was measuring accurately. There was nothing wrong with it. So it's very important, and as a final kind of thing for this video and for this series, is to show that when you have an error code on any of these components, particularly throttle position sensor is your main initiating one, you can get error codes on any other air induction related component that is referenced, because whatever your problem is, it's not something that the computer recognizes as being a fault with that component. So the MAF sensor, before you replace a MAF sensor, again, I have yet to see a problem where replacing the MAF sensor fixed a problem out of my own personal experience, out of dozens of people on this channel, and out of literally hundreds on chat rooms and forums. If nothing else from this MAF video series, you are unlikely to have a mass airflow problem, especially if it is related to some type of air induction issue that you suspect, except for a hot wire MAF being dirty. So we've showed many methods of testing the MAF. One of them that I forgot, that I overlooked, the least of which, if you are expecting hesitation problems with your MAF, all this kind of stuff, one simple thing you can do, remember, if you've got a MAF, you're going to have a MAP sensor. The MAP sensor is going to work with your throttle position sensor as a backup strategy in the event of failure of your MAF sensor. Simply disconnect your mass airflow sensor. If you get a dramatic improvement in your symptoms, then maybe you might start targeting that a little bit better. Almost invariably, you will not, however. So that's another little trick you can do. But again, it comes from taking advantage of knowing how these various components are interconnected. So hopefully that'll help you prevent making misdiagnosis. And that will also go ahead and round out this series. I was going to do another part with talking about the MAF engine versus the MAP only or speed density engine, and different performance things that you would consider, vacuum leak diagnosis you would consider. I think I'm going to save that for a separate video because it's just kind of different material, not necessarily linked with a mass airflow sensor. So we'll go ahead and close this video series out. Thanks for watching. I hope you found this helpful.